write this down. I don't really need more than much more than this. So what this polarization index really says is that. So let me write down. Okay, so before I do that, let me write down the Gini coefficient, and then you will see what I do. This is uncannily similar to the Gini coefficient. So this is the Gini. Okay? And remember, the Gini is the same as the fractionalization index that I talked about before. Okay? So let's just try to understand the Gini coefficient once. Take a person with income X, take a person with income Y. Look at the antagonism between the two, okay, which is Y minus X. Weight that by the number of people at X. Weight that by the number of people at Y at alpha. That's the fractionalization index. The index that I just axiomatized looks very similar, but behaves in a very, very different way. And the reason it behaves very differently is because of this power alpha. Okay? What it does is that it gives group numbers an additional weight. Okay? And so if I could have gone on with the slides over there, I would have shown you additional conditions under which you can prove that alpha has to be equal to 1, which means that this power here is squared. So the particular measure, the polarization measure that I'm going to use, is given by this. You add up over all income groups n of x squared times n of y times y minus x. Now the interesting thing is that even though I've talked about this from a completely narrow income-based perspective, you can apply this particular measure to any sort of groupings, economic or not. Okay? You can apply this, for example, where x and y are indices not for income, but they're indices for different religions, or they're indices for different ethnicities, right? And of course, then there would be the question of what we mean by the term y minus x. And the answer is nothing really, okay? What we mean for what we would replace here in y is by a general notion of distance between groups x and y. And typically, this general notion of distance, when political scientists apply a fractionalization measure, they take it to be simply binary. It's 1 or 0. Okay? It's 1 if the two groups are different, and 0 if you're talking about two groups that are the same. So one can actually take this particular measure and to the data and apply it to see if there is an empirical connection between this measure.
So I remember correctly that you put a constraint over x, that it should be between 0.25 and...
No, on alpha.
On alpha, right.
Yeah. I didn't put it. It comes out of the axiom. And then you can give additional conditions under which alpha must be.
Right.
Yeah. Okay. Now, what I'm going to do, what I was hoping to do today was tell you about a very interesting empirical exercise that was actually carried out by two economists at Pompeu Fabra. Their names are Marta Reynal and Jose Montalvo. And what they do is actually take this particular measure. They did this in 2005. It's a very nice paper in the American Economic Review. Okay? And I wanted to discuss a little bit of their results. And also then to go back to some of my own work on this. But before I do that, I want to say that this particular measure, I want to try and convince you a little bit that this particular measure has very different properties from this. So just philosophically look at this measure for a second. So imagine that you take a society with 3 income groups, okay? One here, and one here. You take the second and the third income group and collapse them into one income group. Okay? Just collapse them, just change society that they get collapsed into one. Now, an inequality measure will tell you that inequality has come down. And more important than that, it will tell you that inequality has come down independent of the context, that there was another group sitting here. It's independent of the context. It's a local. Inequality is a local idea. If there's a transfer from rich to poor and you put them together, inequality will come down. But now try to think about this just intuitively from the point of view of polarization. Try to take two groups, put them together, knowing that there is a third big group over here. Are you going to say that polarization has come down or has it gone up? And the answer is, I cannot tell you until I know about the size of that other group. Okay? For example, if that group is half the population, and this is a quarter and a quarter, and I put them together, then I get two halves. Okay? It's highly polarized. But if that third group over there was almost nothing, was almost no one there, and I take two groups here and put them together, then polarization has come down. Okay? So polarization is contextual, right? In the sense that whether it goes up or goes down depends on the overall configuration of the distribution, and not just on the local properties. And the very interesting thing, which if I had the slide, I would show it to you, is that this particular measure behaves in exactly that fashion. And this one never does. So that's one property. Okay. So let me then go on from that and now talk about how one links this particular measure to conflict. Okay? So now there are two approaches one can take to linking these measures to conflict. And I was planning to talk about both of them. Okay? The one would be empirical, which is the work by Montalvo and Reynal-Carroll, and the other would be theoretical. Okay? So theoretically, the interesting question is, can one write down a model of conflict, a simple game theoretic model of conflict, which will show you that the extent of conflict in society is directly related to polarization. And in the next part of this talk, which I will not get into in any detail, I write down a model of conflict. Okay, and I'm going to show you the outlines of that model, and I show you in that talk, in that part of the talk, that the degree of conflict in the system is directly connected to the amount of polarization. So for that, I need an eraser.
It's on the table.
Say again?
It's on the table right next
Oh,
to it.
got it. I can't find the obvious things. So here too, I'm going to be very quick because I was totally relying on the slides. Okay? So let me talk about so a simple model of conflict. And I can tell you a little bit about how economists approach these ideas. Okay? So here again, there are n groups. And there is a resource, there is a prize, okay? And these groups cannot agree on how to divide up this prize. They cannot agree in a friendly way, okay? So they are competing to seize control over this prize. Okay? So each group devotes costly resources. So each group devotes costly resources. You can't see that, right? Each group devotes costly resources, and the probability of winning, for any group I is the total amount of resources contributed by group I divided by the total resources being supplied by everybody in the society. And then this prize, when it's seized, okay, is divided. Bear with me. Polarization conflict, right? So measurement theory can suggest, but it cannot establish the link between polarization and conflict. So there's two approaches that I was talking about. One is theoretical, write down a natural theory which links conflict with these measures. Right? And the other is empirical. Take the measures to the data and see if the measures talk. Okay? So I first discuss the theory very quickly, and then I'll talk a little bit about the empirics. Okay? So I'm sorry, but between that point and here, I've left out a lot of material. It doesn't matter. It should still work. So here's the model that I was so unsuccessfully trying to write down on the board. Okay? So here's a model of conflict. There are n groups. There are people, a number of people in each group. Okay? N is the total number. The groups can't agree how to divide an overall budget, money, resources, ideological tolerance. Okay? So they fight for all of it. The winning group gets full control. The chances of winning depends on the group resources vested in the conflict. This is what I was trying to write down. Members of the group contribute these costly resources. The total contributions per capita in this society, all the contributions in this model is wasteful. It's just to try and grab that price. Okay? And therefore my measure of conflict is this particular waste. Okay? All the resources. So, what does a winning group do in this model? Suppose it wins. There's a fraction of the output of the winning prize, lambda, that is spent on public goods, and the payoff to a member of group I is, so Uij, I is if the group I's favorite public good is produced. I is a member of group I, and J is the public goods, the favorite public goods of group J. Okay, so Uij is the public goods payoff to a member of group I if a single unit per capita of the optimum mix for group J is produced. So group J mixes. And the remainder is privately divided among the winning group. So a quick summary of this, is, if this figure works, is that the payoff to a member of group I is the public goods payoff, which is UII, plus the private goods payoff to him, which is from the remainder of the prize, minus the resource costs. Right? In case group I wins the conflict. And if group I loses the conflict, the payoff is simply the public goods externalities it gets when the other winning group, J, produces its favorite. And as I said on the board, the win probability is proportional to group resources. So in this model, how do people make contributions? I'm running out of time here. So they, let me skip this. There's basically a description there of how people make contributions. I'm sorry about this. This clicker doesn't seem to be working.